We now know the spike protein is very dangerous.
Very dangerous.
Is biological.
We also know, so if it was very dangerous, but it did what the brochure on these vaccines says it should do, which is lodge in the membrane of the cells that are doing the transcribing, it would be a lot less destructive, right?
I think that's fair, and you're right. It's not just the the documentation about the vaccine. It's the prior literature that was put out by the people that developed it, that developed these clones. So they were aware that there was a risk of a spike being biologically active and having adverse events if it did not stay stuck to the cells that were transfected, that got the RNA and made it. Okay, and they used a genetic engineering method of putting a transmembrane domain on it to ensure that it stayed anchored and stayed put. And they did limited non-clinical studies to say, looks like it stays stuck.
Right.
We engineered it to stay stuck.
They did.
And they published that. Here's the thing.
Specially engineered.
Okay, is that that's generally not good enough in a non-clinical data package. So before we get a product released to use in humans, in the normal situation where we're not in a rush, we have some really rigorous tests that have to be done in animals. And revealing that spike gets cleaved off of expressed cells and becomes free is something that absolutely should have been known and understood well before this ever gotten put into humans. So I'll just leave it at that.
All right. Well, that's
the smoking gun.
Let me just make one thing clearer. You said it very clearly, but lots of people who aren't familiar with this aren't going to get it. Okay. So the RNA gets into the cell. It is translated by the ribosome into a protein. In this case, it's the spike protein, which is the best target on the coronavirus.
We could debate that, but go ahead.
But it's at least a very good one. It's